In this problem, we're going to find the intersection between a line and a plane. Okay, so you may notice that this is the Cartesian form of the equation of a plane, and here is the parametric form of the equation of a line. Okay, so what we want to do is we want to know, when does this line intersect that plane? So I have each of these solved for x and y and z are all solved in terms of t. So I can plug in my x, my y, and my z and figure out at what time does this line hit that plane. Just a quick little note. Remember how if they had given it to us as x plus 2 over 6 equals y minus 3 over negative 4 equals z plus 1 over 3. This is the Cartesian form of the line. So then you'd have to work your way back, set each one of these equal to t, and hopefully, if that doesn't make sense, go back and watch some of my previous videos or check out the connection. If they had given you the line in this form, you can still do what we're about to do. You would just need to set each piece of this equal to t, then solve for x, y, and z. Then you'd be back to where we were. Okay, sorry. So I'm going to take x, y, and z and plug them in. So I have 7 times, well, x was negative 2 plus 6t. I have plus 11, y was 3 minus 4t. And plus z was negative 1 plus 3t. I didn't save space, but equals 19. Okay, so negative 14 plus, I'm back in algebra 1, plus 42t plus 33 minus 44t minus 1 plus 3t equals 19. What does this give me? That's a negative 2t plus 3t. That's just t. Well, that worked out nicely. 32 minus 14, 32 minus 4 is 28, minus 10 more is 18. Okay, so that was a positive 18. Oh, sorry. Oh, look at this. So now subtract 18 and I'm at positive 1. So that means that at time 1, when this line is at time 1, whatever my units are, it's intersecting this plane. So we have answered what time it happened, but we have not answered where. Okay, so I need to plug in 1 into each of these right here. So that becomes my x value would equal negative 1 plus 6 times 1 is equal to 4. My y value would be 3 minus 4 times 1 is negative 1. And my z value, my z value had been negative 1 plus 3t, so negative 1 plus 3t is 1, and that's equal to 2. So where do they intersect? They intersect at the point 4, negative 1, 2. And keep in mind, if it's a point, you've got to write it this way. If I want to know what's the vector, let's say this is the point k, because that's our favorite letter. If I want to know what the vector OK is, the vector from the origin to point K, then you can write it this way. But this is not a point, this is not a vector. So this is a point, okay, and this is a vector. Hopefully that's helpful. What I would suggest that you do is I would suggest you prove this one right here. Okay, so pause the video. Does that fit in there? It says, show that the intersection between this line, and I left it in parametric form for you, there you go, and this plane is this point. So if you don't get this point as your final answer, you did something wrong. So prove that, so do your work. I'm probably not going to do it for you, but if you don't get this, you didn't find the intersection correctly. Once again, when they say show that in IB, show that means you can't plug this in and assume that it's true. You have to pretend you don't know the answer, do the work, do what I just did in that last problem, and then your final solution should be this. Basically, they're just helping you out so that if this were part A of a problem, now part B would use this answer. And so if you did nothing here, you could still at least move forward in part B. Okay? So don't plug it in. Sorry. Solve this, pretend like you don't know the answer, and then verify that that really is the answer. Good luck.